Yeah, I
How did
mean,
you
with
tell your wife that it was like, yeah, we should move across the country because I'm going to go do this other thing now?
yeah, I have a very patient and supportive family. I often think of my wife and three kids as employees or members of whatever company I'm at, but just without a W-2.
Welcome to Manufacturing Mavericks, the podcast that introduces listeners to the people who are driving advanced manufacturing to new heights. Powered by the Barnes Global Advisors, Manufacturing Mavericks host John Barnes and his guests explore the opportunities and challenges of AM, sharing thoughts on industry trends, breakthroughs, and leadership, while sprinkling the conversation with doses of life lessons and dad jokes. Now here's your host, TBGA founder, John Barnes.
Hey there, and welcome to Manufacturing Mavericks from TBGA. I'm your host, John Barnes, founder of Barnes Global Advisors and Metal Powder Works. Thanks for joining us. Let's get into it. Today, joining me is Kevin Kassekert, who's the new CEO at VulcanForms. Thanks for being the first guest on our retooled show.
Thanks for having me. Excited to be here.
So to start off with some good eye rolling, did you hear about the two antennas that got married?
No, I didn't.
The wedding was okay. The reception was amazing. Hold for applause.
Did I tell you about the book I'm currently reading on anti-gravity?
No.
Yeah, it's impossible to put down. I knew we were going there, so I figured I needed to match you one for one.
Awesome. So anybody that's still with us,
Yeah.
so
If you stick around past that, you're gonna love the rest of the pod.
yes, for sure. So naturally, the listeners will see why we decided to do this podcast together. And so you and I met at Rapid this year through a mutual colleague. I think we had this epic conversation. It spanned macroeconomics, process economics, scale up, additive, parts production. I can't even remember all the topics that we covered. If
Yeah.
anybody was listening to us, they're probably like, "What is that?"
What are you two talking about? Yeah, exactly.
So before we get into that, let's learn a little bit about you, get to know you a little bit better. So you're a Minnesotan.
I am. Yeah. Maybe I'll give you my background. So, mechanical engineer by education. Was a university. I'm a University of Minnesota Engineering Institute of Technology grad.
Big Ten
And Big Ten. Yeah.
or 20
Um,
is
yeah. It's grown. Yeah. It's no longer the 10. But yeah, and then spent the first 13 years of my career in the semiconductor industry. But I just generally love building things. I'm an engineer. I love taking things apart and building things, and I've always really been drawn to operations. Like I love manufacturing and figuring out how to optimize for efficiency and the ever chasing struggle of improving OEE and all of those types of things. So that's just something I've always loved since I was young. So I decided to go in engineering and then really focus my career on operations and manufacturing, and largely U.S. based advanced manufacturing has mostly been what I've worked on. Spent the first 13 years of my career in the semiconductor industry, which is what moved my wife and I from Minnesota out to Silicon Valley. So we moved out there in 2002 for what was supposed to be just a few years, and was in the semiconductor world. And they said, after my few years that I had committed to, they said, "Hey, we're ready to send you back to Minnesota." And we said, "Yeah, no, this is like really nice out here." So we ended up staying in the area, and did a whole host of really interesting capital expansion projects and operations, manufacturing, engineering leadership roles in the semiconductor world with a company called Cypress Semiconductor. And then I went with the divisional spinoff of theirs called SVTC. It stood for Silicon Valley Technology Center. And what we did was we took our advanced manufacturing fab and did novel silicon technology development for startups through established companies. And they would come to us for access to our equipment and our engineers, and we would help them design novel silicon technology. So it did stuff all the way from early LEDs to DNA sequencing, silicon-based technology. And then in 2012, I was recruited out of that industry to Tesla, where I was really excited to kind of dive into all of my roles have primarily been sustainably focused. I got very involved in California's energy crisis and solar and all sorts of things, and found what Tesla was doing really, really interesting, not only from the mission and the leadership team, but also just the opportunity to learn a very, very complex supply chain from a manufacturing perspective. It's really hard to build a car, right? You have 4,000 distinct parts that all need to come together at the same time to build a vehicle. You can't ship a vehicle without carpet. So like that's as important as the battery pack or the engine if you're building an internal combustion engine car. So decided to jump out of the semiconductor world and jump into the advanced manufacturing vehicle side. And then obviously, Tesla's technology was incredible and not only applicable to transportation, automotive, but also grid level energy storage, which is something I found really, really interesting, is taking the battery technology that they had developed and applying that to residential and grid level energy storage and how to kind of optimize utility scale energy consumption. Instead of building these peaker plants that run for 3 hours a year, how do you use renewables during the day to charge batteries that can be deployed at night? And cost was a very large kind of inhibitor to that. So then got involved in built up the supercharger network across the country with a great team of people, and then led the site selection for where the first gigafactory was going to go. And then wherever that was going, my wife and 3 kids and I were leaving San Francisco and moving somewhere. Didn't know where we were going. We just knew we were leaving and going to go to another place to go build the world's largest battery factory. So that led us to the Lake Tahoe, Reno, Nevada area, and we turned a giant mountain into one of the world's largest and most efficient battery factories. That factory is now producing over 6 million batteries a day. It's really mind-boggling. So built that, and then along with the factory in Nevada, we built our own EPC team, engineering, procurement, and construction team, to build it ourselves, to make sure that our cost and our speed and our quality and our safety interests were all aligned to our objectives. And we also knew we were going to need to build more of them. So that team then went off and built Giga Shanghai with the folks in China, and we built Giga Berlin with the folks in Germany. And then a lot of those folks are down in Austin, Texas now working on that and building a whole host of infrastructure. So super interesting and exciting opportunity to build advanced manufacturing facilities and kind of rethink how things are manufactured and built. And then in 2020, early 2020, I was asked to join Redwood Materials with JB Straubel, who is the co-founder at Tesla, co-founder and CTO. He decided to go focus on his company Redwood, and so I joined JB as chief operating officer, and we grew that from a small startup into a much larger established company focused on end-of-life lithium-ion battery recycling and turning that into new battery materials to supply it right back into the supply chain. So kind of, a metal atom doesn't cease being a metal atom at the end of its life. It's just in a product that it is no longer working. So we had developed technology to recover and recycle that metal and turn that into new battery materials. And then they've recently launched a new product line where they're actually, before recycling batteries, there are still some batteries that have still a good state of charge and could have a second life application. So they're working on some of that stuff too. So instead of having to go all the way to recycling, maybe it's a reuse case. So pretty interesting stuff going on there. And then, wanted to shift my focus a little bit further upstream even. One of the commonalities between all of these career opportunities I've had has been metal. It's like semiconductors and vehicles and batteries and all of these different things are just different formations of metal structures doing different things, but all kind of linked together that way. And I love manufacturing, and I see a kind of this interesting inflection point in near net shape manufacturing, or complex. Maybe a better way to think about it is like complex product, advanced next gen product manufacturing, where we're at this point where additive manufacturing is starting to actually, the cost profile is starting to come down to a point where it's starting to really change how people design and build next generation metal products. VulcanForms, among many others, have really aimed to kind of crack the code on how you do that. And so what I'm doing is I joined the company almost a year ago to help lead it through its growth phase, right? This kind of disruptive scale phase, and really aimed at widening the aperture of the company, thinking about how do we attack the overall supply chain from the time a metal atom is mined out of the ground to the point that it is delivered to a customer in whatever market or industry. And so we're thinking about that from a first principles of physics approach of what are those steps, Where are there opportunities to simplify the process, consolidate, eliminate waste, drive scale and efficiency and innovation? And the future is really exciting. It's actually really bright. There is an opportunity to kind of shift and change the way things are manufactured at a completely different cost profile. And I know this because I've done it a couple of times now. So it's like I see the same opportunities in next gen metal product manufacturing as we saw in batteries and battery materials and recycling. So yeah, having a ton of fun. We've got a great team here. I'm honored to be a part of it.
Well, I can imagine that there's a couple of threads to pick there, but the one that similarly, I was at a prime, Lockheed Martin and Honeywell, and so kind of moved back down the supply chain, working with people who make parts, and I think probably this timing is good because you're coming in with the consumer of parts.
Yeah.
You have an expectation of what the part is meant to be doing. There's a drawing. It really should meet the drawing. It's not a suggestion. This is what we wanted to do. Yeah, it's a requirement. Yep. And then I think that's where sort of additive is. I recently gave a talk at Edison Welding Institute called "It's Time to Move Out of the Basement." So previously I'd said it's like this awkward teenager. It's going to be great, but it's a little stinky and a little smelly right now. And now it's time to it's making money. It's making some money. It needs to make more money, and it'll move out of the basement. It's also interesting around the supply chain. I don't know that anybody used the word supply chain, at least my kids, until COVID. And then in some ways it was a blessing and a curse because it was like this oversimplified concept. Supply chains are really complicated, and it isn't just about the paper plant can't make the toilet paper and there's no trucks to get it to Costco. As we always used to say, there's no unimportant parts of an airplane. As you were just saying, all the parts of a car are important too.
All got to be there. Yep.
You can't ship some parts to the customer later on. Is there kind of the common thread? You said it was metal. That's maybe the technical piece of it. Is there additional metal complexity? How do you think about that? Like, how did you tell your wife that it was like, yeah, we should move across the country because I'm going to go do this other thing now?
Yeah, I have a very patient and supportive family. I often think of my wife and 3 kids as employees or members of whatever company I'm at, but just without a W-2, right? Because it takes as much focus and dedication and support. It's a family affair. So this was a family decision, and I can honestly say that.
I often say they're shareholders, and I may or may not be the CEO.
Oh, there you go. That's probably a better way of saying it. As far as the additive portion is just one small portion, an important portion, but a small portion of the entire ecosystem. And so, the first step is analyzing what is the supply chain today? How does it work? And that very much started with early days for me, a first principles approach of, like I mentioned earlier, metal coming out of the ground to the point it's made into its final product. And so I went and mapped that out, and I took one of the customers that we have, and I just mapped out like where does the supply chain come from today? And what I found wasn't surprising because I have done this a few times, and it's always pretty eye-opening when you do the first analysis, that this customer, the metal atoms interface with over 9 countries and travel north of 20,000 miles throughout its life cycle to get mined out of the ground and ultimately become an end product that's delivered to the customer. And that has a whole host of customs delays and shipping and carbon footprint and tariffs and just all sorts of supply chain vulnerability and interruptions.
Erupting volcanoes.
Yeah, erupting volcanoes. We saw all of this, come to light during COVID when shipping lanes and things like that, and people weren't able to move product as easily. So it started
when they parked that cargo ship in the Suez Canal diagonally for a while. So who would have seen that coming?
That was just a mishap. But so it starts there, and then you kind of outline what are the steps inside of that ultimately aren't providing value to the product. And all of that shipment, the only reason that has to happen is because you're moving, supply chains, you're moving from company to company. but 40 to 50% of the final cost of the product was just in moving metal. It wasn't actually improving the product. It was just moving it from one spot to the next. Um, and that's necessary to some degree. Like you're not just going to go build everything on top of a mine and have everything live there. Um, but there's opportunity there. And so then the next step was like, okay, understanding the cost profile of that supply chain and where are there opportunities to either to eliminate steps, to simplify the process in the supply chain, to consolidate steps, where there are opportunities to innovate and do things better and more efficiently. And then how do you ultimately scale that? Like what is your North Star? Like everything we do at VulcanForms, similar to what we did at Tesla and Redwood, here it's targeted at cost per kilogram of delivered final product. Like that is our North Star. Every decision we make is to try and drive a minimization of the numerator and a maximization of the denominator. So like drive cost down and scale volume. And that's how you start to really drive a kind of a whole new cost profile. Part of that is in the additive space is taking metal and turning it into powder and then turning it into a near net shape, right? And then you have your post processing and everything that happens with that. What our company was founded upon 10 years ago, we just celebrated our 10-year anniversary. Our founders envisioned a world whereby they could fundamentally make product at high volume and lower cost. And so they didn't see the right platform being developed, so they developed that technology. And we're now leveraging that technology along with other technology, but leveraging that in a high volume production state. So we've figured out how to take powder and turn it into a near net shape in a very, very efficient way. But it can't stop there. You can't take very expensive powder and then efficiently process it and then inefficiently post process it. The whole thing has to work because your customer is looking at the end delivered state. They're not just looking at how efficient were you at one particular step. Much like you go to a TSMC, they're not going to optimize just their photolithography. They're going to optimize the whole thing and then drive scale. So we're taking a very similar approach to kind of a fabless semiconductor model where we happen to have designed equipment that is very efficient, but then we're leveraging that in more of a product delivery platform in partnership with our customers.
And so I guess at the level that you're at now, you're not a buyer of I'll call it parts or technology. You are the technology, so you have a strong influence over the direction that it goes. Was that sort of the appeal to? Because you seemed in our conversations, like,
yeah,
it's clear that you like the economics. Like, I don't want to work on 1% of the problem. I want to work on 20% of the problem, or whatever the major cost driver is.
Yeah. The appeal was the technology we have developed, we can leverage to do some really interesting things, but it wasn't solely that. For me, the appeal was also a team of people that are aligned around a mission of fundamentally changing the way advanced metal products are manufactured. You have to have that mindset to chase that, and you have to have the culture set such that people want to go after that. The other aspect is our investors. Like that is very much aligned with the investment thesis of going and building out the domestic manufacturing supply chain and shifting how and where things are manufactured in the world, right? So we're very much a U.S. based advanced manufacturing company right now, and that's where we are aimed right now. There's so much new technology nowadays with AI and machine learning and robotics and automation and scale and just different ways to do things that you don't have to go overseas to be able to compete, right? You can actually build things. It's actually better and cheaper in some instances to build things here because you're closer to your end customer. There are also things that just can't be built overseas. We do a bunch of aerospace and defense work. They just can't buy from foreign adversaries or things like that with that supply chain risk or potential IP risk. And so there's some of that, but it was kind of that combination of like, okay, this is the time to double down and really drive advanced manufacturing forward. And so that was exciting to me. It was like a chance to, I've been able to kind of leave my mark, and this gets into a little bit more of like who I am as a person, of what my goal is in life is But it was a chance to really kind of revolutionize yet another industry, which I think we were able to do in the solar and semiconductor side, along with vehicles and energy storage and battery manufacturing, refining. Like I very much, it's kind of what drives me is I want to leave this world a better place for my kids and their kids and future generations. And so I do that through kind of three vectors of being a good husband to my wife, being a good father to my kids, and working on things that I think are important to the future of humanity. And it's tough to make sure that the number three doesn't get in the way of one and two. Like it's a tough balance. But we've got a great support network, and I don't know, we're having a lot of fun doing it. And like, who wouldn't want to go work on cool problems like that?
Yeah.
It's why you become an engineer. It's why you go into the career of your choice, like to go really work on cool things, and it's a lot of fun.
Yeah, for a minute there, I thought you were going down the path of the project management triple constraint. Pick one, optimize for the second, and let the third float. But
Yeah.
I'm glad to see
No,
that
no,
there's a.
definitely not. I do not let any of them float. Try not to, at least. It's a tough balance.
So that kind of takes us into there's two pieces here. I'll let you dealer's choice. So kind of digging into VulcanForms. I'll say making the pivot from making machines to making parts, and maybe that was the plan the entire time. But
Yeah.
I do actually very much appreciate this focus on dollar per kg, because really at the end of the day, the competition is other forms of manufacturing, and
Yep.
you have to be adding value some way. And I remember taking my Six Sigma training at what was then Allied Signal, now Honeywell, and it said value add basically is if the customer would pay for you to do it twice, then it's value add. If they won't pay for you to do it twice, in other words, doing it once, if you did it a second time, you're not adding any value. So that was a really interesting way to look at value add activities. So I am cynical of companies that are making printers one day and making parts the next day, because I actually feel like making parts is a very difficult family to be in. It's very demanding. It's being consistent. It's making the same thing every day, but at the same time, having a culture that's innovative, because you can quickly become outdated and you're going to get replaced by something else. So I know at Lockheed, I always appreciated there was a couple of companies that we would work to, and they worked very hard at showing we have good ideas. Once we move it over to manufacturing, like, this is it. We're doing this, and we'll come up with process improvements. But if you don't like them, we're not tinkering here. There's that piece of it, and it is a little bit combined with there's a culture there. And as I used to say, what I learned at Lockheed Martin was there really aren't any technology issues. There's only people issues.
Yeah.
And how do you get people, the mixture of personality types and all these different things marshaled and moving in a common direction? So maybe your choice, how do you see, I suspect you're a believer in all of those things, but the question is like, how do they come together?
Yeah. I mean, so the company was founded to be a production company. It was not founded ever to develop equipment and sell equipment. They saw an opportunity to develop equipment because there wasn't anything really targeted at high volume productivity at the time, right? It was there was and this was 10 years ago. The world was very different. The additive world was very different at the time, but it was very much to develop technology to then leverage that in product manufacturing. So there hasn't really been a change as far as the strategy goes. Think of it as kind of like a TSMC seeing an opportunity in an etch process, and nobody was developing the right etch tool, so they developed it themselves, and then they're leveraging that. But our goal is to be a metal product manufacturing company. It is not to be just a 3D printing company. I have to remind people of that a lot. It's like it is much, much more than just designing and developing our own printing technology. So much so that we will eventually partner with others in other technology. There is no single tool that can do every type of tech, right? There's not the perfect solution for everything out there. And so, we have developed a tech that plays in one aspect. If you think of like fill rate versus productivity, we play in a corner of that, and we play very well, leaders of the world in that. but that doesn't often meet some other requirements. And so, we work with others where that makes sense. And then we'll continue to develop technology where we think we need to. But quite frankly, if somebody is out there and we can leverage that, like I don't see us going and building our own 5-axis CNC mills, right? There's people that are doing that today, and I need that technology to do post processing and finishing, but I don't need to go develop that tech. It already exists. There's people that are building really robust depowdering solutions. Okay, like great, I'll go leverage those. But if I see an opportunity where we could improve upon it, or it meets our needs at a lower cost, then we'll go develop that tech. And that was a lot of similar how we approach things at Tesla and the Gigafactory. Was innovate where we needed to innovate, but if there was something off the shelf that met our needs from a cost and quality and timing perspective, then we would work with those folks. So similar approach here, but it boils down to, I kind of break our engineering thoughts, or maybe our operation, into three sections. So you've got powder, you've got printing, and you've got post processing. And so we've set up our engineering teams and our technology roadmaps to drive a cost per kilogram curve on each of those. But like, we don't manufacture our own powder today. Like, we work with the experts in the world, and we should continue to, as long as they're going to get down that curve, right?
Mhm.
But we've got to drive that supply chain, and so that is a very important component of our overall cost of goods sold. And so we got to make sure we have robust partners that are driving that. Otherwise, there's no way we can compete globally. We've done some really good work on the printing side, and now we're starting to really focus a lot more on the automation of our post processing as well. So it's kind of, looking at those three components and putting them together, and then wrapping a digital software solution and an AI solution around all of that, and then scaling it. And then think of that ecosystem as kind of the factory footprint, and then think of the factory as a machine in and of itself. How big should that machine be? What is the capacity of that machine? Where should that machine go so that it is most effective for our end customers? What metals, what materials should it produce? What markets? It's a fun dynamic, and like kind of a fun equation to go solve, but a lot of variables at play.
And so how do you, you made it sound simple, and I know it's not simple, because you actually do have multiple shareholders. You have actual shareholders, you have employee shareholders, you have
Yep.
families that are depending upon this. And so what's your overall ethos in that people management aspect? I mean, it was interesting
Yeah.
when I looked it up on LinkedIn, the VP of people and places. I was like, so I didn't know whether that was a personal touch or whether that was
Yeah.
something else, but there's a, yeah. So let me just leave that there.
Well,
Like,
my
it's about
leadership
marshaling.
ethos, yeah, my leadership ethos led me into that role, I would imagine. Since early days, probably before I even started my career, I have very much subscribed to the belief that leadership is a support role, right? The people that I've always enjoyed working with and for have felt more like supporters of the initiative than bosses and top down leaders. It's like, so I've always been a people centered leader with a servant mindset. I truly believe it's my job to support the team and not the other way around. That's what I think leadership is, and you should lead from the front lines, and you should be there with the team every day. That's why we moved our family across the country to be here every day, so that I can understand the problems and be a part of the solution. So that, with kind of that basis, when I was building and leading teams at Tesla, I was asked to step into I was, at the time, I was leading, doing real estate and construction and facility operations and a whole host of other things, and I was asked to take on the people leadership role. And I don't have a formal training in HR, but what I do have is a very strong belief in a servant leadership, and I understand the operation of the company. I understood the engineering side of it to a certain extent, not all of it. Very talented engineers there, and so I stepped into that role to help, right, to help build the company and and drive our culture forward. And but we had a really awesome team of HR professionals and recruiting professionals and total rewards and compensation and benefits professionals. But I was asked to step in to kind of help kind of grow and mentor and lead that team. But with a servant leadership, you step in and it's more around, I wanted to make sure that the vision of our team aligned with what the mission of the company was trying to accomplish, and then I would make sure that team had the resources and the support that it needed to do their best job. And I ask, and I do this here too. I ask a lot of questions on how can I help, right? It's my job to put the resources there, and then hire people that are better at better at it, smarter than I am at their core competency, and then largely kind of get the hell out of the way and let them do their jobs and support them. And so it's a lot of that, and setting up your management operating systems to make sure that you're guiding and monitoring and managing, but it's very metric driven, and then making sure that the people have the support that they need. And that's just back to the optimism part. Like I'm an optimistic leader. I believe that the world can be a better place, and it is all of our jobs and to ultimately leave it that way, and to try and improve upon it every day. So I
Yeah.
do that through a series of different ways.
Yeah, I think that optimism versus positivity, one of the things that that I've kind of come to embrace. I wouldn't say I was always a very positive person. I think as a younger person, I was probably very cynical, shocking for an engineer,
Yeah.
a realist, but have become optimistic in my later years. And so I found the sentiment that being positive is in the present and you can ignore real problems, but
Yeah.
optimism accepts adversity while working on solutions. And so
Yeah.
I strongly appeal to that. It's a forward-looking statement. It cynically, it also reminds me of the quote from Dennis Holey: "Expecting the world to treat you fairly because you're a good person is like expecting a bull not to attack you because you're a vegetarian." So, there's a balance. Is
Yeah.
I think what it comes down to.
Yeah.
I think a couple things. So around this, so we both studied engineering. I'm sure the programs are very similar. And at Purdue, it's strong. It's a strong technical foundation. It digs into the fundamentals, and it's about problem solving, and it's about doing these things. But there's not a lot of room for electives.
Hmm.
And so I'm imagining that you didn't have like a lot of extra time to study leadership and those types of things to know that you're interested in it. And
Yeah.
so I'm kind of curious, like if you had to go back to the 20-year-old version of you as an ME student or an ME student today, I always kind of suggest like, yeah, get the fundamentals down
Yeah.
and then add to it with soft skills and things like that. And those are hard to come by.
Yeah. I realized that I'm really good at identifying my informal mentors and learning from them, both the good and the bad. That started probably in my college years. I was one of those students that worked very hard to put myself through school. I didn't spend spring breaks partying down in Daytona Beach or anything. I worked, right? I worked in the summer. I did road construction in the summer. I worked in the winter time and during spring break in Minnesota, which is a lovely time of year. I
I was
remember
gonna
I
say
was I
summer's like
was
what, 2 months?
yeah, I was cleaning scaffolding and shoring outdoors, knocking concrete off of rebar, like doing stuff like that. And just, through that time, you interface with a lot of people and you kind of develop your work ethic, and your management ethos. And then when I came out of college, well, actually, before I did a co-op program, in college, and which was probably the most valuable part of my entire career. Early days was I would go to school for a quarter, and
Hmm.
then I would go to work for a quarter, and then I'd go to school for a quarter and go to work for a quarter. And so you'd work full time, and I learned more on the job, out in the field, like seeing how to actually. I worked at a filter manufacturing company, and we were building automation equipment, and I would, you'd interface with a lot of different engineers and different managers and bosses and everything. And so you kind of learn, like, I was always fascinated by who did I enjoy being around and how could they motivate the teams to be their best. And it was often positive interfaces, right? It wasn't top down fear based leadership that got the most out of people, right? And also, like, who wants to work around that? Like, who wants to get
Hmm.
screamed at all day long? I don't. So, like, that was something I always loved about Tesla, to be honest, is it wasn't that type of environment. It was a hardworking, no BS type of environment, but we deplored negativity. It was like, let's go work on really cool things and have fun doing it. So that was kind of my, from a management perspective, what I really enjoyed. Yeah, and then it was, kind of on the job training as I went. I came out of engineering school wanting to go into operations. So like my first job was actually I was a night shift production supervisor on a test and sort floor in the basement of a semiconductor factory. Like I worked a compressed shift. I worked Wednesday through every other Saturday, excuse me, every other Wednesday through Saturday. It was 6 p.m. to 6 a.m. shifts, but as a manager, right, you often had to show up at 5 p.m. and stay till 8 a.m. to update the day shift. So, and then you're off Wednesday, you would basically be required to come in on that Wednesday anyway. So you basically worked 4 15-hour days a week. But that, like, you can't get much further away from the core of the company than being at a remote fab in the basement at night, right? And so, like, I learned how to interface with that team. We were very close knit, and it taught me a lot. And then I actually did take some formal training in management and supervisor classes and leadership classes. And then I decided to go get my master's so that in my MBA. But it was very much focused on leadership and management, because I loved, engineering school had taught me how to solve problems, but it didn't really teach me how to interface with people very well. Quite frankly, how to present and get your message across and write papers and things like that. So I kind of honed in those skills and then applied that to the operational side of things. And I generally hate inefficiency. Like, it drives me nuts. It's like nails down a chalkboard when I see inefficiency. So that led me into like looking at the energy grid and how people consume energy. And then I moved out to California for a project, and that was when the California energy crisis was happening, rolling
Mm.
brownouts and blackouts and Enron and all this stuff. And I'm like, why is this happening? So I bought some books and started reading about it and met some folks at Cal ISO. And I'm like, this doesn't need to happen. Like, this is not real. Like, wait a minute, what's going on? So what are we doing to actually improve the efficiency of the energy grid? And then that got me into solar, and it got me into energy storage, and it kind of grew from there. Actually, I was hired at Tesla. My first role was the director of energy efficiency. Like, that was the role I was hired into. I had 0 employees. No, I wasn't managing anybody. I was a team of one, trying to figure out how to efficiently scale the Fremont factory, from an energy efficiency perspective. And I loved it. It was a blast. But we had no building automation system. It had been torn out. So it was me. I would come in every Saturday morning and walk around this 5.5 million square foot factory to 17 different substations and manually monitor each of the transformers to see like what was our loading and our meters. And so then I would identify, we walk around, you'd see a bunch of lights on in areas that you didn't have people, you'd hear motors running where they weren't running operations. And it was like, okay, let's go shut those down and turn those off, because it was just silly. And then it was like, okay, now we go automate this stuff and make it a lot better. So I don't know. It's just, it's fun solving tough problems.
Well, I think there's I would say out of listening to that, there's a couple things. One is it's great if you know how to solve the problem. It's better when other people know how to solve the problem.
Right.
And the second thing I always say, a friend of mine at Lockheed, he came to me one day, and I had groups in three different states, Palmdale and Fort Worth and Atlanta. So I would go to Fort Worth, once a month because that's where most of the people were. And
Mhm.
so he called it management by walking around. And I said, oh, I
Yeah.
just like to get my hands on the data and if I don't have my hands in the data, I don't know how to solve the problem because I don't know
Yeah.
what the problem is. You can
Funny.
talk about the
We
problem,
used to
but
do the same thing. We had the management by walking around. Funny story similar to that. You mentioned data. I remember very early days in my career, we were trying to solve this photolithography problem in the fab, and the engineers thought it was related to change of humidity levels, right? And so humidity bands are very tight in the photolithography area, and the rate of change is also very important. And so they were blaming the facilities team, for having, the humidity's changing. And so I went and pulled a whole bunch of data and I analyzed it, CPKs and all of this stuff, all these calculations. And I went and met with the site director and I sat down. I said, "Look at all of this data." And he goes, "That's great, Kevin." I was like 25. He goes, "That's great, Kevin. What does it mean?" And I'm like, I go, I will be back tomorrow with an answer for you. And he just laughed. And that was the moment in time I realized the big difference between data and information.
Yeah.
And so I
Yeah.
came back. I'm like, all right, here's what this is telling us. This is not the problem. He's like, okay, very good. Thank you very much. And then we went and found where the issue actually was. But
Yeah.
it was a very funny early learning opportunity for me.
Well, I have one other anecdote, and I'll ask you if we've missed anything that you wanted to talk about. But so it kind of related to that. When I was an intern, I worked at a metallurgical lab, and we were asked to do a forensic evaluation of a putter that had failed. So it was a golf company that made these putters, and they were experiencing an issue. And so they asked me to take a look at it, and there was a PhD that had studied this, not at our company, but at a different one. And they were asking for a second opinion, basically. And I'm like, I'm just a punk kid. I'm like a sophomore.
Yeah.
Like, this guy's got a PhD and a bunch of experience. And so I went through and I looked at it, and I actually looked at the process map, and I read this guy's report, and I went to go my supervisor, and I was like, I'm really confused. He goes, why is that? I go, well, this guy with a PhD said the problem is in this process step. And they go, well, that makes sense. What's wrong with that? I go, they don't do that process step. So,
Yeah.
again, go back to the data.
Yeah.
To your point,
Yeah,
you got to
exactly.
turn that into some information. Anything that we haven't covered that is important to you?
Well, I'd love to hear your perspective on where do you see advanced manufacturing in the U.S. going? You've got a really unique perspective. Look at a lot of different technologies, a lot of different approaches. Where do you see it headed, and what do you think are the constraints to being globally competitive right now?
Boy, that's a light one.
Yeah, that's probably a loaded question, but
Yeah, well, I suppose it comes as no surprise. I mean, I'll say I tiptoed into this. I didn't mean to. Similarly, like I didn't mean to get into additive manufacturing. So, like we're doing this Neighborhood 91 project. We have a resilient
mhm.
manufacturing program now with the Secretary of Defense's office.
I've got my key.
Got your N91 key.
Yeah, that's right.
And I think that to me, that's the future, which is if you look at maybe like I'll say a false economy in other places, they spend massive money on infrastructure, and then it's basically given to somebody. And so maybe the energy isn't being paid for, maybe the equipment's not being paid for. And so the problem is that drives you get what you reward, I think,
Yeah,
at the end of the day, whether you
yeah,
intended to or not, that's what you get. And so I do strongly believe that the US and the Western world of free market capitalism prevails because it punishes inefficiency and it rewards
yeah,
efficiency. And that has to be true. As soon as that doesn't become true, then everything, I mean, you can create your own world, but
yeah.
it basically, quote I saw recently was, gravity doesn't care that you don't believe in it. And
Yeah.
and so we did a study and we looked at vertically integrating versus other forms. And so vertically integrating is the fastest way to do something. It's also the most expensive way to do something.
Mm.
And I remember talking to the guys at Lockheed Martin. In our facility, we made B-29s back in World War II. We actually made the rivets for the B-29s in that
Wow.
facility. We had transformed to, hey, we don't do that stuff. We're expensive, so we need to do the really high value things. And I think that's a lesson for everybody, which is focus on the high value things, or don't focus on the low value things.
Yeah.
First point is it high value or low value? You get your hands on the data and find out. If the customer is not willing to pay for it, probably not
Mm.
high value. And so I think that there has to be, I'm really intrigued anyway around the notion of free market vertical integration, if you will. So
Hmm.
campus-based manufacturing, you and I have discussed this at length. You have your version of it.
Yep.
I think we both agree that it's if you can get it done where a free market comes in and everybody handles their own efficiencies, that is the path.
Yep.
That's I think the area that I'm pretty efficient or pretty emotionally tied to. And I think my experience with Neighborhood 91 is that when you put that message out there, you get the companies that want to be a part of that message,
Hmm.
which seems obvious in hindsight, but
Yeah.
wasn't obvious to me when we started.
Yeah. It's like saying the best way to build a product is to only build the product that needs to be made.
Right.
Yep. Okay. Yep. That
Okay.
makes sense.
Yeah.
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 Yep.
So yeah, I think that I think there's some real challenges out there, but roughly there's about 500,000 unfilled manufacturing jobs today, and there
Hmm.
seems to be mostly unfilled because they're high skilled. Fixing that problem is a challenge. I turn my attention to the male female piece. So I remember there was a great quote from George Bush Sr., I believe. He went to Saudi Arabia and he goes, the problem with your country is you're only allowing half the work to contribute. Half the population
Half the population, yeah.
cannot contribute to what's going on.
Sure.
So I just look at it as brains. Everybody has a brain. If we're excluding 50% of the brains, and we can't afford to do that because we have other countries like China, which have a much more populous country. So we need all the brains that we can get. I don't really care what shape they come wrapped in.
That's right. Yep. Totally agree. Well, cool.
Well, fantastic. Thank you for being part of the podcast. Thank you for your efforts in pushing manufacturing forward and making it look like a cool job. At least we think it's cool, whether our kids think it's cool.
Yeah. I think our kids think we're pretty cool. Yeah, maybe not. We'll see.
Maybe not. We'll see. Yeah.
Well, I appreciate the invite. I appreciate being a part of it. It's always fun to explore this stuff with thought leaders.
All right.
Cleared for takeoff.
You've been listening to Manufacturing Mavericks, hosted by John Barnes and powered by the Barnes Global Advisors. Take a moment and subscribe to our channel.